MacMaths, let's do some maths today. Okay, good morning. I'm going to go through questions now from exercise 11E. This is quite difficult, guys. Well, some of the questions are. In fact, number 4 is a bit of a monster. I'm going to do them in a pure vectors way. There's other, and actually in some cases better ways of doing them. But you're going to struggle with these. You've got all of the knowledge. The knowledge is just the triangular laws. But it's just whether you can apply that to trickier situations. They obviously start off fairly straightforward, but then they get trickier. So I'm going to go through those. So it's exercise 11E. So you're only watching this if you're doing exercise 11E. Have a go at them first. Put them on pause, and I'll talk you through them. So first question is this one here. You've got it on the screen, yeah, just checking that. So question 1, you've got this diagram here, and there it is, and you're told that this is A, this is B, and this is C, going in those directions. You're told that this distance here, this is X, Y, and Z. You've got to prove that A plus C equals 2B. You're told that that distance here, let's get some different colours involved here. You're told that that distance and that distance are the same. Don't look the same on mine, but they are. X, Y, and Y, Z. Okay, so let's just use the triangulation. X to Y is minus A plus B. So X to Y is B minus A. Okay, Y to Z, that one, is minus B plus C. Minus B plus C. So minus B plus a C. That's how you get from Y to Z. So Y to Z is equal to C minus B. Okay, now you're told that XY is equal to YZ. So XY is YZ. So all of that is equal to all of that. So minus A plus B is equal to minus B plus C. And when we rearrange all of that, you can see what's going to happen. I'll take the B over there, so I've got 2B, add A to both sides, A plus C, and there you go, you've got it. Okay, so number 1 is fairly straightforward. Okay, and you can see it's all of these we're going to do by doing this triangulation like this. Okay, so let's get rid of that one and put that to one side. Just try and, you know, I'm sort of thinking as I'm doing these as well, so I hope I don't make any mistakes, but just bear with me if I do. I will spot them and correct them. Okay, on this triangle here, okay, you've got these are all the midpoints, these ones here. So there it is, and the reason I'm doing this, so I don't want to be writing on that, are B, Q, P, and A. And this one, it says that OP is P, so O from there to there, that's a P, and OR from there to there, that's an R. Okay, and what have we got to do? We've got to find OB. Okay, so OB, well, OB is easy. Okay, OB is just 2R, because that's the midpoint. Okay, so that's straightforward. PQ here to here. The first thing that we need to do is to go from P to Q, we've got to go up there, no problem. That's just a P, isn't it? Because it's half, you know, that's a P and that's halfway, so that's a P as well, going in the same direction. But it's this one here. AQ is half of AB, so let's find AB first. AB is minus 2P plus 2R. So AB is equal to 2P minus, what am I doing here, plus 2R. So it's 2R minus 2P. Okay, so 2R minus 2P. So that means that AQ is equal to half of that, which is R minus P. So that is an R minus P. Okay, that's that. Okay, and now what we got to find, we've got OB, so we've got that one. PQ, okay, so now we want PQ, do it here, PQ, and PQ is equal to 2P, hang on, no, from P to Q, so I'm going to go up P, that's a P, let's put that on, that's a P also there, plus R minus P, and P take away P is not, so it's just equal to R. Okay, so that is equal to R there. Okay, so we've got that, and we've got that, hence prove that they're similar triangles. So now they're saying this one and this one have got to be similar triangles. Okay, well they're similar if you can see that the ratios of the sides are all the same. We can see here that we've got PQ, and I want you to compare PQ to OB. Okay, so I want you to compare PQ to OB. Well, PQ is R and OB is 2R. In other words, you know, it's twice the size. Okay, so that corresponds to double that one. You know, we turn this upside down, you can sort of see. Now, the corresponding sides are this one and this one, aren't they? So I want you to compare PR to AB. Okay, if we compare P to R to A to B, well, P to R is minus P plus R. In other words, R minus P. And this one, A to B, we already did that one, didn't we? Okay, that is 2 lots of that. So it's 2 lots of R minus P. Okay, or 2R minus 2P. And you can see that it's just times 2. Okay, and so the last one is we just need to prove that this is the last side here. If this side is twice that one, then all the sides of the big triangle are twice as big as all the sides of the smaller triangle. Okay, so that one we know is 2P. So let's compare RQ to OA. Okay, well, OA is 2P, isn't it? That's 2P. Now this, we've got to prove that that's P if they're similar triangles. So R to Q, okay, is minus R plus 2P plus an R minus P. That's, we've gone from R to Q, gone dit, dit, dit. And the R minus R plus R goes 2P, take away P is P. So just fitting it in is P to 2P times 2. And you can see that all the sides of the big one are twice the 3 sides, the corresponding sides of the smaller one. Okay, so that's that proof done. A bit untidy. Okay, but I'm sure you've got it. You can watch that again if that was too quick. Let's rub that out. Yeah, number 3 is a funny one, really. And it's almost a little bit silly. I'll show you why in a second. We've got this triangle here. O, B, A, M, N. And it tells you O to M to A is 2 to 1. So this is sort of 2 to 1, okay? That ratio there. Okay, and it says that the whole of OA is an A going that way, and the whole of OB is a B going that way. Now it tells you that MN from there to there is parallel to OB. Okay, so oh well, let's do it in a pure vectors way. First of all, what I'm going to do, it's asking you to find ON in terms, so from there to there, that's what it's asking you to find, ON, in terms of A and B. Okay, so what I'm going to do is I'm going to go from O to N in two different ways. I'm going to go up and along to there, and I'm going to go to the top and down to there. Okay, so to do this, what I'm going to do is I need to work out what MN is and AN is. Okay, now first of all I'm going to go what MN is. Now MN, it says it's parallel to B, so I'm going to say that it's some fraction of B, isn't it? It's some multiple of B if you like. So I'm going to call it mu B. I don't know what mu is. Might be a half, might be a quarter, might be a third. It's a third. But I don't know what that is. Okay, that's MN. And AN is some fraction of AB. Now, I know what AB is, because AB is minus A plus B, which is B minus A. So AB, so AN is some fraction or some multiple of AB. So I'm going to call that lambda, because in vectors we tend to use these Greek letters mu and lambda as a first protocol. So I'm going to say that AN is some fraction of AB. AB is B minus A, so lambda AB. Okay, now my ON, let's get ON. Well, ON we can do it two ways. We can go, because this is 2 to 1, O to M, okay, plus MN, we can do it that way by a triangle, to there and to there, and O to M is 2/3, isn't it? So it's 2/3 of an A plus an MM, which is mu B. Hang on a minute. Yeah, that's right, 2/3 of A plus mu B. But I could say that ON, let's go right to the top, so that is an A, and it's plus that bit AN, which is lambda of B minus A. Okay, so I've got it two different ways, and because I've got it two different ways, I can now say that 2/3 of A plus mu B is equal to A plus lambda B minus A, can't I? Okay, I can say that. Now, it looks horrible. Let's multiply this out. I can say 2/3 of A plus mu B is equal to A plus lambda B minus lambda A. Okay, and I'm running out of space, so I'm just going to move that up there for you. Okay, I'm just going to rearrange it a little bit. I'm going to go 2/3 of A plus mu B is equal to, and I'm going to put my A lambda A minus lambda A plus lambda B there, and I'm going to go 2/3 A. I'm going to do another line in here. I'm going to factorise out this A. I'm going to go 1 minus lambda. I'll tell you what I'm doing in a second if you haven't already spotted lambda B. I've done this before, and you can see what I'm going to do here is I'm trying to get it so that both sides look in the same format. and I'm going to equate the coefficients. If this side is equal to that side, then what's in front of b on both sides has to be the same. So now we can see that mu is equal to lambda. I can see that from there to there. I can also see that equating the a's, that 2/3 is equal to 1 minus lambda. Okay. In other words, moving that over there, lambda, and moving 2/3 over there, we can see that a lambda is a third. If lambda is a third, okay, then mu is a third. All right. And now we can answer the question. O to n, of course, O to n is 2/3 a plus, and its mn is mu b, but mu is a third, so a third b. You can see that. Okay. The question does go on. It says that show that an to nb. Well, we've already worked out that from this bit here that lambda was a third, so you know that's a third of the way along, so it's 1 to 2, isn't it? So we've done that as well. There was, of course, I don't know if you sort of spotted this, but I mean, it was a bit of a silly question. There's a lot of maths here just using vectors, but actually we could have just used similar triangles. This side here, you know that this angle is the same for both. There's my little triangle drawn here, and there's the big triangle. So that angle is the same as that one. Because of corresponding angles, that one and that one are the same, and that one and that one are the same. Okay. Okay, so you can see here that this triangle and the big sort of triangle, you know, are the same. 3, let's do 2 there. Don't know what I'm doing there. Okay. So the big triangle and the little triangle are the same. So if this side has the ratio of, because the angles are the same, if this, and we know that because that side is parallel to that side, which creates these two angles, and then obviously the third angle the same. So if this is 1 to 3, then it's 1 to 3 for all of the sides. So this side has to be a third of this one, and this side here is a third of that one from similar triangles. So there was actually really nothing to work out here. You could have just done it from similar triangles and not using the pure vector method that I've done here. Okay. Likewise with question 4. Question 4 was a monster, and my daughter and I spent some time on this one. We did this one the first out of the section, and had I done this one for this one, I don't think we would have spent as many times. We did in fact find 3 ways of doing this, but again, the pure vector way, you can see this is a similar triangle. This is a square here, so this is a similar triangle to that there rotated round. So you can, a little bit more complicated, but you can do it a lot easier and quicker than the way that I'm going to do it using similar triangles. Okay, it's not the way that the book wants you to do it. The book wants you to do it like I did the last one, using you know, pure vectors. Okay, so that's the way I'm gonna do it, and it's good for you to see this. Okay, so here it is. This is a, like I say, it's a bit of a monster. That's the midpoint. That point there is 3/4 of the way. That's Q. That's 3/4 of the way up. Okay, that's P. That's O. That's A. That's B. And that's C. And that's M. Okay, and OA all the way up there is an A, and all the way along there is a C, from O to C. And it says find OP. Okay, here we go. To go from O to P, and I hope you follow this, I'm going to try and do it slowly. There's 2 ways we can do, we're going to look for 2 different routes for doing this. We're going to go halfway up on a long MQ, okay, to MP. And we're going to go right up to the top on a long AC, but stop at P. So those are the two routes we're going to take, that route and that route. Now, if we're taking those routes, I need MQ first of all, don't I? So I'm going to work out what M to Q is. M to Q is a half of A plus a C minus a quarter of an A, and I hope you're okay. It says that's 3 to 1, so that's a quarter down minus a quarter A. So MQ is equal to a half A take away, so it's a quarter A plus a C. So therefore I'm going to do the same thing. I'm going to go MP is some fraction of that. So I'm going to go, let's go with lambda, a quarter A plus C. So some fraction, you know, I'm going to call that lambda, so it's some multiple or some fraction of a quarter A plus C. Okay. I also need AC, don't I? So AC, a little bit easier, A to C minus A plus C. So I'm going to do it the other way around. So minus A plus C, there's my minus A and there's my plus C, and I just did it a little bit quicker. And of course, so therefore AP, going from there to there, is also some fraction. Let's use our mu. Okay, so I've got those two. Now, same as what we did on the last question. Now we've got those, O to P. Okay, so O to P. O to P is OM, which is a half of A. I'm going to go straight to it now. Half of A plus MP. So it's plus, and MP is lambda, a quarter A plus C. Okay, so that is how to get it. So half of A plus, you know, some fraction of MQ that we've worked out. Okay, that's MP. But it's also equal to an A, a full A, plus AP. So full A plus an AP is mu C minus A. So it's also equal to that, full A plus mu, lots of C minus A. I'm going to do the same thing. I'm going to multiply out these brackets and equate coefficients, and that way I can work out what lambda and mu is. Okay, and once I've got what fraction along, okay, we've done it then, we've solved this problem. Okay, so let's do it the same. If this is equal to this, let's multiply that out. So we've got a half of A plus a quarter lambda A plus lambda C. Okay, so I've just times that out, and that is equal to A plus mu C minus mu A. I just know I'm going to go wrong here. There's so many mu's, lambdas, A's, C's, and so on. Okay, so I'm trying to be careful. So I've got all my A's together here. Okay, I've got all of my A's together, so I can go half plus a quarter lambda A plus lambda C. Okay, and if I factorise out here, I've got 1 minus mu A. What I've done is I've moved that to put it with that A there. Okay, so I've done 1 minus mu A, that gives me 1A minus mu A plus mu C. Okay, so I've got that now. Okay, again, like with the last one, what's in front of C is got to be the same. So lambda and mu, I knew that was coming. Lambda and mu are equal to each other. Okay, but that is one equation that we've got. mu is equal to lambda. Another equation that this gives us by equating coefficients is that a half plus a quarter lambda, hang on a minute, yes, is correct, Mr. McRae, is equal to 1 minus mu. Okay, so I've got that is equal to that, yeah, okay, coefficient of those two. If I times everything by 4, I get 2 plus lambda is equal to 4 minus 4 mu, okay. And I know that mu is equal to lambda, okay, so I'm going to swap my lambda, okay, with a mu. So I've got 2 plus mu is equal to 4 minus 4 mu, okay, so 5 mu is equal to, take 2 off both sides, is equal to 2, mu is equal to 2/5, okay, so if mu is equal to 2/5, lambda is also equal to 2/5. Okay, so I've got those now. So can we find OP now? We can find OP. We can use either one we want. This one looks the simplest. So OP, let's get a nice different colour. Getting excited now, getting to the end. Let's go with orange. Okay, so OP, let's pick one of the OPs. Bit of a mouthful that one. This version of OP is A plus, now mu is 2/5. 2/5 of C minus A. Okay, that's OP, but let's tidy up. We don't want A's in two different places. So OP is equal to A plus 2/5 C minus 2/5 A, multiplying out my bracket, and A take away 2/5 A is 3/5 A. So 3/5 A plus 2/5 C. So that is OP. In the back, might have taken a fifth out, I don't know. If you take a fifth out, you've got 3A plus 2C, factorising. Okay. We've also, it does say show that P divides AC in the ratio of 2/3. Well, we've found that the fraction of this is 2/5. So if it's 2/5, that's 3/5, isn't it? 2/5 and 3/5, in other words, 2 to 3. So inadvertently, we've also shown part 2 as well. Okay. So that's how you could do that one. You could do it a lot quicker using similar triangles. I can just very quickly show you that. You could have done it, and the book doesn't want you to do it this way, or the other way that I did it the first time I had a go at this. You know that is a half, and this here is 3/4 of that length there, and that's half of that length there. And you know that angle and that angle is the same, and because of alternate angles, or corresponding angles, you know that this angle and that angle, they're alternate, are the same. Okay, so in other words, if you sort of rotate it round, this side and this side are sort of corresponding to each other. Okay, so then if you go with a half of A over 3/4 of A, okay, this is equal to the smaller side over the bigger side is the same, isn't it, as this to this one. okay? So is also the ratio of a half to 3/4. So, but you know, if we call this, you know, mu to, you know, well, that would be like 1 minus sort of mu, okay? So you could do it sort of that way, and you know, if you did that, the A's cancel. You just got a half divided by 3/4. A half divided by 3/4 is a half divided by 3/4 is a half times 4/3, which is 4/6, which is 2/3. Okay, so now you've got mu to the 1 minus sort of mu, whatever. So you can see that this is 2 parts to that, which is that bit there, which is 3 parts. That's it, 2 to 3. This bit solved sort of straight away. If you know that, you could have done it for that one. That would be also 2 to 3. So, and you know what AC is in terms of small a and small c. You know, it's minus a, c minus a. So it was, you could have done it a lot quicker just using that simple sort of similar triangles. I've got to confess, the first time I did it, I didn't even spot that. I just did it on a graph and went, that's 4 units up, so that's 2 units up, and then I just did equations of straight lines, you know, going from there, and just did the coordinates and just solved, got the equations of 2 straight lines on a grid. You know, you can say, well, coordinates 4 along and 4 down, so that line there would be x plus y equals 4, that one, and this one here, you know, y equals mx plus c. You can see for 4 along it goes up 1, so that line to there is y equals a quarter x plus c. Okay, so those are your equations of your 2 lines. You know, you just did them on a grid and made up and said that's 4 and that's 4. The reason I chose 4 is because you can go half, but you could also go 3/4. And if you solve those, you get that coordinate, and from that coordinate you can work out the ratios, because it just tells you how far along the 4 it is. So you can do it that way as well. There's 3 different ways of doing that question. Okay, and I'm not going to, it's going to spend forever doing these questions. There's another couple to do, but I'm just going to do one more. You can have a go at the last one yourself. I've not even looked at the last one. And I'm not even going to do this one as well. But I'm just going to show it to you. ABC is equal to 5, 8, 4, 3, and 7, 6. If I was doing this one, okay, 5, 8, you know, this is, in terms of I and J, it's 5 along and 8 up, okay? So that's the coordinate 5, 8. This is the coordinate 4, 3 here. Okay, and this is the coordinate 7, sort of 6 up here. You can do it that way. You can do it in terms, just change these to I and J. If you want to find the modulus of those, the distance between the two, it's just Pythagoras, isn't it? Of the gap between them. So what did I do? I did A, no, that's A, that's B, and that one is C. Okay, so you can just work out the gap between them then. So A to B, those two, once you've got your diagram, you can see it's just 4 to 5, so it's the square root of, so A to B, the modulus of, okay, so that's the magnitude of, isn't it really, is 1 squared, and 3 to 8 is 5 plus 5 squared. Okay, so you can get that distance, and you can do the same with A to C. 5 to 7 is 2, 8 to 6 is 2, so A to C is, you know, the square root of 2 squared plus 2 squared, so that's the square root of 8, and B to C, you know, 4 to 7, 3 squared, 3 to 6 is 3 squared, so 9 is root 18, that's root 18. So you can do that, but it says it wants you to find all the angles. Okay, from 4 to 3, to go from there to there, okay, you've got up, if you work out that angle and that angle the same way as I was just doing that then, so the angle from there to there, 4 to 3 to 5 to 8, well, the 3 is the up to the 8, that is tan to the minus 1 of opposite would be 3 to 8 is 5 over 4 to, so the inverse tan of 5, and then from this to here, from the horizontal, that is tan to the minus 1 of 3 to 6, which is 3, and 4 to 7, which is 3. So tan to the minus 1 of 1, that's 45 degrees. That's 45 degrees, that. So if you take the tan of the inverse tan of 5 from and take 45 degrees away from that, you've got this angle here. Okay. Once you've got this angle here, you've got the 3 lengths of the sides. You could just use the sine rule. So that over the sine of that is equal to that over the sine of that, and use the sine rule. And once you've got 2 of the angles, then you can just work out a third, because they add up to 180 degrees. Okay, sorry about that little mistake, just proves I'm human. Okay, and I hope those are okay for you. Okay, but have a go at those first before you watch. Well, I hope you've had a go at those before you've watched all of this video. Some tricky questions there. There is another one, I haven't even looked at that one, the last one. Okay, number 6, but it's going to be no harder than number 4 or number 3. Okay. I think I'm going to call it a day with the vectors. The vectors just go on to the problems with this 11F, and that is it's really applying it and forces and so on, but we're going to do all of that. I don't like the fact that it's starting to use equations of motion and so on. We're going to do all of that in mechanics anyway. We're going to cover all of that and more, and in more depth, so we don't really need to do 11F, okay? But do have a go at some of the mixed exercise questions and see if you can apply the vectors that you've learnt over the last few lessons, the last 5 lessons, to these questions as well. Okay, you will find you'll get a lot better at vectors once we've done the mechanics. I'm not so sure it should have been in the AS. Okay, they've moved it there. It wasn't last year. It's a couple of years ago. Okay, in the old A level. All right. Okay. Bye bye, guys.